Today I'm introducing you to Eve Brennan. She's from Business Insider, who is one of our silver sponsors. So that's amazing. And she's here to ask the question, what if your personal data could become your most knowledgeable health advisor? And she'll be talking specifically about type 1 diabetes, and that's very prominent because if you don't know, it's Diabetes Awareness Month. So really, really good topic. And without further ado, Eve.
Thank you, Rachel, and thank you everyone for joining. I hope everyone's been enjoying the talk so far today. I was emceeing down the Lagan room this morning, so I know the standard's been really high, there's no pressure. But I've swapped my pink Fulham t-shirt out for the presenting gig. But yeah, my name is Eve Brennan. Today I'm going to be talking about something that is right at the edge of where personal data meets agentic AI. And that is how to build your own MCP server. But before we get into the tech, let me tell you about why I care about this. So I've worked in tech for about 7 years now. I started out as a software developer, then moved into cloud and DevOps because I love working with the tooling that helps bring that software to end users faster. But I still get the same joy from writing code and still see myself as a software developer at heart. By day, I work in the cloud engineering team at Business Insider, one of the sponsors here today, which means I get to see both sides of the tech industry, both how it's built and how it impacts businesses and users. Outside of working hours, you'll find me running DevOps Belfast meetup or curating for the Bell Tech conference that happens every March. Over the last year, generative AI has gone from being kind of fun side projects and chatbots to becoming a real productivity booster for me in my day job. Before I knew it, I was using GitHub MCP server to manage Terraform module upgrades and the Atlassian MCP server to do all that somewhat annoying Jira ticket updates. MCP going mainstream made me really want to learn how it works under the hood and build my own one. But the project I selected isn't just about AI, it's actually quite personal. And the photo of me on the right is me as a 5-year-old. That is the year before I was diagnosed with type 1 diabetes. Because of type 1 diabetes, my body cannot produce insulin, so from the age of 6, I've had to manage that myself. As a result, the technologies that's had the biggest impact on my life isn't AI, it's actually the continuous glucose monitor. It's a little medical device I wear on my arm, and that uses Bluetooth and NFC to transmit readings to my smartphone in real time. It's absolutely incredible, but the data can be quite overwhelming, and I need to be able to interpret it correctly to be able to gauge food intake and insulin doses. So I started wondering, what if I could make AI understand the data for me, safely, privately, and on my own terms? That's what led me to create a model context server. So with that context, this is what we're going to cover. I want you to be able to walk away from this talk knowing what the model context protocol actually is and what it isn't, and also how you can build your own MCP server, whether it's for personal use, developer tools, or just to experiment. My goal is that you leave this session with just enough understanding and curiosity to build one. Let's get into it. This time last year, AI assistants were increasingly capable of generating text, reasoning, and doing tasks, but they were still effectively siloed. Each system or data source required its own custom connector. This slowed down development, reduced reuse, and limited broader adoption. To tackle this, Anthropic came along and introduced the Model Context Protocol, or MCP. MCP is a universal open standard that acts like a USB-C port for AI applications. This allows external systems to plug into any model via a common protocol. And this reduces friction for developers building AI-augmented applications by giving them SDKs and reference implementations. In short, MCP solves the bottleneck in AI's ability to access external systems smoothly and consistently. So this will be the slide with the most text on it, probably. So this is all the components that actually make up the MCP specification. At the base layer, we've got the core protocol. And the two bits when you're building an MCP server that you really need to think about are the transports and the authorization. If your MCP server runs locally on your machine, like the AWS API MCP server, for example, you'll want to go with standard in, standard out. This is also quite helpful if you need to access local credentials on your machine. But if it's running remotely and you want it to be accessible over the internet, then you'll use HTTP. Authorization is optional in the specification. You don't need it for an MCP server, but when you do add it, it has to be OAuth 2. I'll come back to this a little bit later when we talk about authentication flows. Above that, we have the MCP client layer. This is the piece that handles the connections between large language models and MCP servers. So examples would include Copilot, Claude Code, Cursor, even ChatGPT as of a couple of months ago, and also your own custom applications. And finally, we have the layer that we're here to talk about, and that is the MCP server itself. So MCP servers have three types of components: resources, prompts, and tools. The demo I'm going to do is mostly going to cover prompts, which are predefined templates that guide how the model interacts, and tools, which are executable functions that allow the model to perform actions or pull in data. So that's the landscape of the MCP stack. Now that we have an understanding of MCP, let me demo the MCP server that I created. So in this case, I'm using the MCP server that I built with Copilot, and you can see there how I authenticated with my username. I was already signed in before, so it didn't bring me into the browser. So this is a pretty simple example as far as being a diabetic goes, but I used natural language to ask how Halloween a couple of weeks ago impacted my blood glucose levels. Usually it's a little bit of a nightmare when you're snacking on sweets for trick-or-treaters. So as you can see here, I use the natural language query, and then my MCP tool goes. It decides what dates to check, so you can see how it does start date and end date for the evening of Halloween. And then it connects to the tool I use for my continuous glucose monitor. So this takes a little minute to run. And what I go on to do next here is I use an MCP prompt, which doesn't really get as much love. They're quite handy for the use case you'll see here. So an MCP prompt is like a predefined prompt, and I'm able to input, as you can see here, I'm putting in the description of the sweets that I ate while I was sitting snacking, while I was doing the screen recording. And it means I don't have to write out a full prompt for the large language model. So this goes, and then finally I ask Copilot to upload the estimated carbohydrate count to my continuous glucose monitor app using another tool that I created. This helps me to track carbs so I can decide how much insulin to take and also spot trends in my glucose levels more easily. But blood sugar isn't just about food and insulin, it's influenced by stress, sleep, hormones, exercise, illness, even the weather. So many subtle factors that a lot of people don't realize. And the real challenge is connecting those dots, understanding why the highs and the lows happen so that we can tackle them appropriately. My ultimate goal for this MCP server is to be able to integrate it with other data sources and MCP servers so that I can link glucose data with real-world events, so that I can uncover those correlations and manage my diabetes more intelligently. This is a remote MCP server, so I hosted it on Amazon App Runner. There are some dedicated MCP server hosting options in AWS, like Agent Core or Cloudflare has an option too. I'm sure there are others out there. But you can host your MCP server wherever you want, really. Now, let's unpack how I built it. So before any MCP magic, I needed a reliable data source for my blood glucose levels. And normally, people like me view our glucose reading on a mobile app created by the manufacturers of our continuous glucose monitors. But there's actually a whole open source ecosystem behind diabetes tech, driven by people who decided not to wait for pharmaceuticals to innovate fast enough for our needs. One of the coolest parts of this movement, I think, is the NightScout Foundation. They've built open source tools that let diabetics access, visualize, and share their glucose data, and even create their own closed-loop insulin pump systems. These people in the photo I met at the NHS Hack Day in Kanos back in October, and they taught me about the NightScout Foundation. I had no idea about it before, but it was a real light bulb moment for me. I've actually adopted it in the last month and started using it myself. But this ended up becoming the backbone of this MCP server, and it's the API that my MCP server connects to. Every reading, every data point flows through that open source project first. Without the folks at the NHS Hack Day, this talk probably would have looked a bit different, so kudos to them. So I had the external tool at this point that I wanted to MCPify. It was time to start coding, and for me, that started with choosing the right library. At its core, MCP servers run on JSON RPC, a lightweight, stateless protocol for remote procedural calls. It's about sending structured JSON messages to trigger actions or retrieve data. But most developers, like myself, maybe don't want to handcraft JSON RPC messages, so using a good library or a framework makes life much easier. Thankfully, there are more libraries available than we have time to get through. The main two, however, that you should probably be aware of if you want to build your own is the official MCP SDK and FastMCP. The official MCP SDK is the reference implementation. You can define your server, the tools, the resources, the transports. It's fairly bare metal, but it comes in a variety of programming languages. Meanwhile, FastMCP is a Python framework. I actually really like this one. It has support for auth providers, a testing framework. It can actually generate MCP servers just based on an API spec. If I were to start my project all over again, I think I would have gone for this. I know these aren't libraries, but if you want to stay away from code altogether, there are a few low-code and no-code options available. One of them is the AWS MCP servers, the OpenAPI one. You just provide an API and your OpenAPI spec, and it will produce all the operations in your API as MCP tools and operations and resources. There are even similar options like Agent Core, which I mentioned before, that will take that a step further. And with the same information, it will deploy a remote MCP server with authentication into the cloud. Ultimately, I chose the official SDK because I like TypeScript and I wanted to be able to use the same library that's in all the code snippets in the official MCP documentation. A high code option also made sense to me as I wanted to do some custom transforms with the data. But the takeaway is simple. Pick your abstraction level. Whether you need full control or plug-and-play simplicity, there's a path that can fit your workflow and your security model. So next, I'll show how I start to define the metadata for one of my MCP tools. So as I explained before, tools enable models to interact with external systems, such as querying databases, calling APIs, or performing computations. To achieve this, the first thing you need to do is define the metadata. Similarly to a typical function, you can define the parameters. So for my getGlucose entries tool, I've added the start date and the end date as the input schema. I've also specified the output of the tool, And I've defined the title and description. With the schemas, you can maybe see why I went for TypeScript. This is the metadata that the large language model will see and use to determine when a tool is called. When we look at the input schema, we want to consider the risk of prompt injection, which Niall was talking about in the talk in here before, if you were here. It's similar in a way to SQL injection. We don't want the client to be able to send arbitrary strings or structures. I've used a library called SOD to validate the input schema, and you'll also want to use architectural patterns to prevent atypical invocations of any underlying external system. And side note on the topic of security, it is worth rate limiting your MCP servers to prevent a DDoS attack or prompt engineering gone wrong. Once you have the metadata defined, you can move on to creating the actual business logic. Good MCP servers don't just regurgitate API responses, they curate them. For example, Night Scout's entries endpoint returns a ton of stuff. Mongo collection IDs, timestamps, device info, all irrelevant to my use case. I only needed glucose readings and timestamps. So when I was creating the output schema, I made sure to strip that noise out and keep only what mattered. I also used a utility to convert the blood glucose measurement unit from the American one to millimole, which we use in the UK. And we don't just do this for prompt engineering. It's also quite good for saving tokens, which also improves the output of your LLM. This makes the AI reasoning sharper. And it's also safer because it limits data exposure. It's worth mentioning, too, that if your MCP server has access to an external system, like this one, you should really lock down the permissions that the MCP server has access to in the external system with RBAC. For example, I created a role in Night Scout that is limited to reading blood glucose readings and creating food records, but it doesn't have access to any admin features and it can't do anything to my insulin levels on my pump. At this point, I had a working MCP server, and if I wanted to, I could have said, job done, if I was just going to be using it on my local device. But I wanted to deploy it so I could access it over the internet from my smartphone or my work laptop or whatever it is. And with that, I needed to set up some authentication. Since I was exposing health data, I couldn't really just leave it open to the world. And this actually proved to be the most challenging part for me. But to be fair, implementing OAuth is considered to be a fairly advanced skill. I used Amazon Cognito as the identity provider. I am an AWS girly after all, but you can use GitHub, Okta, whatever. One of the reasons I said I wish I used the fast MCP framework is because it actually has built-in Cognito classes, and I could have just imported those and saved myself from doing a custom integration. But we got there in the end. So here's the flow. MCP client fetches the auth metadata, redirects me to the Cognito's login page where I enter my username and password. Cognito then issues an access token to the MCP client, and that token gets attached to every subsequent request to the MCP server. It's proper OAuth, somewhat painful, but secure. Inbound auth locks the front door to the MCP server, but we also need to manage what happens when the server talks to Night Scout. Outbound auth handles how the MCP server communicates with Night Scout on behalf of every user. Because this MCP server uses HTTP transport, it can support multiple concurrent sessions, meaning users can connect to their own Night Scout accounts without leaking data between them. I stored the Night Scout access token for each user in a user attribute in Cognito. You probably wouldn't do this in production. You'd use a proper secret manager solution, but for proof of concept, it was okay. When the MCP client then calls a tool, the MCP server validates the inbound token that's been given by Cognito, And it used that to look up the user's Night Scout credentials, and then it follows the authentication process for the Night Scout API. With that, we can trigger the tools and get the data back that we expect to. Implementing OAuth is recognized as a pain point in MCP. Authentication improvements are in the MCP roadmap, so I expect we'll see better documentation and support for it in the future. But the bottom line is that it's very secure. Now, no build is done until it's tested. And I just included a screenshot of MCP Inspector because it is very good. It's an open source tool that, it lets you check the auth flow, the tool discovery, the output schemas, all visible in a friendly UI without having to use an associated model. For enterprise situations where you'll want some form of automated testing, there is a CLI mode too, which I'm yet to look into. Some other things in my head to be aware of is that VS Code has a developer mode for MCP server development. You can enable it in your mcp.json config, and that will do things like restart the MCP server every time you make a code change, and it will also enable debug logs for the MCP client, which helps you debug any little niggles. So that's the journey from a personal problem to a running MCP server. The shift from chatbots to agentic use cases represents a big step for AI adoption. In a year, MCP has become the de facto standard for connecting agents to tools and data. In my case, I've used MCP to help better understand my blood glucose data, but it could just as easily mean integrating with CI/CD tools, your Jira tickets, CMS, or any other software you care about. There is some debate about, is MCP here to stay? But I think for now it is a very good standard for being able to use external systems with large language models. So whether it's your health data, business tools, or your latest side project, I challenge you to try building your own one. Not because it's a buzzword, but because it gives you a deeper understanding of how AI and existing software can actually work together. If you'd like to learn more, because I didn't want to come in and just show you loads and loads of code, I have curated a bank of resources, articles, tutorials, research papers, which are all free to use. You can grab them by scanning the QR code, or if you want to follow me on LinkedIn and keep up to date with different DevOps Belfast meetups, feel free to connect with me on LinkedIn. All that's left to say is I hope you enjoy the rest of your day, and hopefully I'll see some of you at the after party.
Now, is there any questions?
Hello.
Hello. First of all, that was unreal. I think it's a really cool use of MCPs. Just a query when you were sort of thinking of this project. Obviously, glucose is just a form of raw data that the MCP is considering. Did you ever consider a machine learning solution as a more direct API and just processing the data directly? Or was MCP always the preferred approach?
Yeah, that's a really good question. I think ultimately I was hoping to learn a little bit more about MCP, but traditional models are really applicable to diabetes. We actually see these a lot for insulin pumps. So whilst I didn't do for this project any traditional machine learning, it's definitely something that is used for glucose.
Any other?
Have you thought somewhere where you're going to expand this idea for your MCP server?
Yeah, I thought you might ask that, Mark. Mark was on the team at the NHS Hack Day. We came forward. So we've explored this a little bit before, but what I would like to do is do things like correlate it with like events in my diary to see, does that influence things? Also things like sleep, when I get a bad night's sleep, does that make it worse? And also want to start and think about, things like, do I need to be changing my basal rate or my bolus rate for my insulin pump in accordance with that? It'd be cool to do something like look back to last year, like NIDC 2024, what were my bloods like that day? And just so I can think ahead, how I need to manage it. So yeah, I think definitely for me to keep it is going to be integration with other systems.
Sorry, I just wanted to cough, but great talk. Thank you very much for that. If anybody hasn't looked at the links you shared, they should, because I think you win the prize for the best resource pack any speaker has shared today. So thank you very much for that. And then I feel guilty for asking, are you going to share your code on GitHub, or do you have other plans for it on that?
This is something I'm thinking about because, the Night Scout Foundation is out there and there's already a really good community of open source projects for diabetes. I'm actually quite tempted to. I think chronic perfectionist, I probably just want to tidy it up and make sure it's all proper first, but it's definitely something that's in my head to do.
All right, well, if there isn't any more questions, there's now an afternoon break. I think there's also still going on in the Cave Hill room a CV workshop, so enjoy.